Open a mechanical hard drive. The inside is not that complicated. Our data is actually stored on this disk. According to the capacity of the hard disk, you can have multiple disks. The disk is mounted on a spindle. Brushless motor on spindle. At 7,200 revolutions per minute. Turn the disk. This is a head wall assembly. There is a wall above and below. At the end of the head wall is a slider and read/write head. Slider by special design captures the airflow from a spinning disk. And we use that airflow. Read and write head. It's suspended about 15 nanometers above the surface of the disk. Hard disk at work. The head wall will always be on the surface of the disk. The head wall retracts when it stops working. There's also a coil attached to the wall of the head, and two powerful magnets up and down the coil. When current passes through the coil, it creates an electromagnetic field. At this moment, the upper and lower magnets will receive a force. Move the head arm across the disk. When the voice coil passes a reverse current, in this case, the magnetic head arm will be subjected to an opposite force. To move in reverse, the voice coil can move the position of the read-write head. Precise control around 30 nanometers. To quickly find the data that needs to be read. The head can be on different tracks per second. Move back and forth 20 times. And can make very minor adjustments. In order to make the magnetic head arm work normally, magnetic coin is through a flexible wire, connected down to a connector. The connector can transfer the signal to the hard drive. And on the PCB circuit board, there is a main processor and a DRAM chip on the PCB. The chip is mainly used as a register, an input and output buffer usage. There's a little chip over here, mainly used to control voice coils and brushless DC motors. The side of the PCB is SOTA port for hard disk. And then all these components, all sealed by a shell. The sealing of the hard disk is very important. If any dust particles enter, disks can cause significant damage, because the read-write head is only 15 nanometers from the disk, and large dust can reach 10,000 nanometers. After talking about the construction of the hard disk, how does a hard drive read data? The data on the hard drive is stored on this disk. The disk is divided into very many concentric tracks. Number of tracks 500,000. These disks are then divided into sectors. Let's look at one of these sectors individually. The previous part of the sector is the synchronization code, for recording the length of each data, followed by an address code, used to tell which track the read/write head data is on. Which sector? And then there's the real data storage area. Each sector stores 4 KB of data. The last one is the error correction code, used to validate data stored in the app. Is it read and written correctly? Now let's zoom in on the disk. Enter the microscopic world. See how the head actually reads and writes data. Write data to disk. This is achieved by the magnetic head magnetizing the disk unit. A disk unit? It's only 90 times 100 times 125 nanometers in size. When the disk unit is magnetized, the north and south poles of all atoms in a disk unit all point in the same direction. In order to achieve magnetization, there is an energized coil behind the right head. When the coil is energized, it generates a strong magnetic field. The magnetic field passes through the right head. Focus on a small point on the tip, and then through the 15 nanometer void. Enter the disk unit. Under the action of a magnetic field, the magnetic field direction of the disk cell is changed. To achieve magnetization, it is important to note that this magnetization is durable. Even if the head is removed, the magnetization of the disk cell remains the same. Can last for many years. When changing the current direction, the disk cell orientation of the disk will also change accordingly. With these magnetized disk units, we can define it like this. The disk unit with the arrow facing up is equal to 1. The disk unit with the arrow down is equal to 0. The definition seems simple, but the reality is not so defined. The magnetic head is tested. Magnetic field directions of 2 adjacent disk units. To define 0 and 1. Magnetic field directions of 2 adjacent disk units. If the opposite, then define it as 1. If the magnetic fields of the 2 disk units are in the same direction, then define it as 0. So when data is written to disk, The write header will be based on the data being 0 or 1. Magnetize the corresponding disk unit. Same with reading data. Reading data is operated through the read head. Inside it are layers of conductive material, made of magnetic and non-magnetic materials, alternately combined. This material is very special. It can be based on the magnetic field strength of the disk unit to change the resistivity. If the resistivity is low, indicates that the magnetic field below is relatively strong. Then the result is read as 1. If the resistivity is relatively high, indicates that the magnetic field below is relatively weak. Then the result is read as 0. To read the final disk data,